Great to see you all again on the HashiCorp 2024. Last year, I presented the part one of the Cloud Control provider documentation journey, and we have made a lot of good progress since then. If you haven't watched it, you can take a look at it on the playlist or HashiCorp 2023 in YouTube. Now, around the same times, Generative AI or GenAI has exploded in terms of popularity amongst regular customers and also a lot of the DevOps or IC community. You likely have tried it yourself, maybe generating a text, answering questions, generating image, and many more. So when we started the documentation journey for AWSCC, we are kind of thinking about how GenAI can also help us to speed up the progress. So in these sessions, you're going to learn practical use case of GenAI to accelerate these Terraform tasks that likely going to take us hundreds of hours if we have to do it manually. By quick introductions, my name is Welly Siauw, based off Seattle, where I work for AWS as a principal partner solution architect. My role in AWS is to help partners such as HashiCorp, and where we co-innovate with AWS on behalf of the customers. AI/ML is part of my area of interest for the last decade or so, and I'm excited to get this opportunity to share these ideas. You can also find me on LinkedIn on the link below. Like any good story, we have the beginning. As I mentioned earlier, AWSCC documentation journey was previously presented at the HashiCorp in 2023. But some of you might have missed it, so I think it's appropriate if we start with explaining what we've been working on, and more importantly, why and what is the missions. So it starts with the problem statement. Many customers want the latest access to AWS feature or services using Terraform, whether that's some new services that may be launched or maybe a new feature that is added recently. As you know, AWS provider is developed by the contributors, where this contributor, on top of their busy schedule, they go and write the code and make a pull request. The pull request has to be reviewed before it gets merged. Now, this takes time, and we always ask ourselves, how can we automate this? How can we make it faster? And that's why the AWS Cloud Control provider, or we call it AWSCC in here, was developed. AWSCC automatically sync and build resources from schemas published by AWS. So it's making it possible to add new feature and services in AWSCC provider within hours or days after the service is launched by AWS. Then, as with any new technology, it'll take time to grow the adoptions. So that's why we started this project to complement what is missing in AWSCC, which primarily do documentations to usage examples. We have more than 100 plus contributors internally who kindly spare their free time to test and also create these documentations. And that's become the example usage for resources in AWSCC. So now we come to the next phase where we want to accelerate this process, what we need to do in order to accelerate this flywheel. Now, in case you're still confused, yes, there are two AWS providers available in Terraform today. So AWS and AWSCC provider. Both providers can be used together, and likely you're going to combine both of those providers in the short to medium long term. At the time of this presentation today, AWSCC provider is not GA yet. So I think for the next couple of months, likely you're going to see yourself using both of the provider in combinations. So guys, in case you don't know, there's a difference between the AWS standard provider and also the AWSCC provider. So let's dive a little bit deeper to that. We start with the AWS standard provider. First, you declare your Terraform configuration as usual. Then you run Terraform apply, which then use this Terraform binary. This Terraform core binary is the one that interfacing with the provider, which is in this case is the AWS standard provider. The standard provider handles the AWS providers handles the resource provisioning across each of the services, say EC2, IAM, S2 bucket, etc. And then in the future, if there's a new services or feature, the contributor will have to write the handler to interface with that new API endpoint or API services. That part is very important. Each new feature or service will require update to the AWS standard provider. And that's because each service API has this unique implementation. Now, imagine that you don't need that Terraform AWS provider to interact with different AWS services, each of these individual services. Imagine that you can interact with just one single consistent Gradle API. So that would make it simpler because this provider would only need to interact with a single API endpoint that has a consistent method for create, read, update, delete, list, and many more. And that's pretty much what led to the development of AWS Cloud Control API, which acts as that single Gradle API for all supported AWS services. So you can interact with this API for all supported AWS services. And then at the same time, HashiCorp also developed this AWS Cloud Control provider that interact with this API. So the major difference between AWS and AWSCC, one, service API endpoint, AWSCC interact with just single API, Cloud Control API itself. AWSCC is also automatically built based on the resource schema published by AWS. So on a weekly basis, this provider scan the schema resources published by AWS, and then it auto-generate the resources, data source, the documentations in the Terraform registry. Now, let's take a look at the problem that led us to explore GenAI. Earlier, I did mention that the AWSCC also generates documentations that you typically saw in the Terraform registry. Now, if that's the case, then why are we here today on this HashiCorp session? So let's take a look. This is the AWSCC Terraform registry. At a high level, you see there's a resource you can select, the schema descriptions. But it doesn't take, trained eye to notice that there is no particular example in here. And we often hear that the first friction point for using AWSCC is that there's no example. So we made an effort. We add human touch to these documentations by handcrafting the example of how to use the resources. Just like how you contribute to AWS standard provider, you can also contribute to the AWSCC provider by creating these examples. At a high level, here's the process looks like. First, you set up your dev environments, and then you pick up the resource that you want to work on, dive deep about it, learn how to use that resources. You might also look at documentation and etc. Then you write the actual example. There's a specific format and templates. You can check it from our past talk about this. And finally, you submit the pull requests, and it will be reviewed and then merged. And then you keep doing it and keep doing it across all of the available resources. So why we are here again? Sounds like we have the solutions to the documentation. So should this session be absolute by now, if that's the case? Well, let's uncover the progress and see where we stand. When we start this project in April, at the time there are about 700 resources in the AWS CC provider. This is AWS resources that you can use in AWS CC. We added about 130 examples since April 2023, which is some progress for sure. But at the same time, there are new features. There's a new service launched by AWS. Plus, there are resources that previously is not supported is now supported by AWS CC. And that brings the total amount of resources that's now available to north of 820 resources by December 2023. So as you can see here, there's a what we call treadmill problem, where we barely keep up with the pace of innovations collectively from all of the AWS services. So that's become our new problem statement. How can we automate the documentations for AWS CC or this example? And can we use generative AI to do that? So we asked the contributors, so you have more contributors coming in. We asked them like, hey, where do we took the most time? Where is the friction point? Where do we spend the most time? And then it's become very obvious that the most time is spent on researching. Not all contributors are obviously familiar with the services that they want to work on, so they might have to read the documentation, they might have to run some tests, etc. They also have to look at for some relevant examples from other sources like AWS documentation, standard provider, Terraform standard provider, and also maybe in CloudFormation documentations. Then they also need to test this and then of course do a validation after you do that. So this is our aim in here. We want to automate this process as much as possible. And for that, we need three things. First, we need to have the schema that's consistent. Like anything you want to automate, ideally, they have something that consistency, because that consistency will help. In this case, the consistency that we're looking for is on the resource schema, specific about like how the resource property and attributes are defined. AWSCC, as I mentioned, is actually built from schema published by AWS. So this resource schema is available in CloudFormation registry. And then every time there's a new services or feature, this resource schema is updated in the CloudFormation registry. And that's what triggered the weekly build on the AWSCC provider, and it scans that resource schema and creates the resource handler, data source, and also documentation. So we have the schema that is coming from the CloudFormation registry and then inherited to the AWS registry. Secondly, we need curated documentation. This is ideally an example or documentations on how to use that resources that has been validated. Good news is we know that a lot of contributors come and use the AWS documentations to learn about that resources, how to look for the examples. In this case, this is a screen from CloudFormation resource example. And this is actually fine because AWSCC provider are actually built from the same resource schema as the CloudFormation. So yes, we can actually use this example. So we have the schema, we have the documentations from one source. Now we just need a smart converter or translator who understand Terraform and also understand CloudFormations, and can act as that translator. And yes, that's where the GenAI comes to the pictures in here. One domain for GenAI is LLM or large language model. LLM is pretty good at anything related to text, such as translating a document, creating a summary of the document, or also generating a code, such as in Python and Java. So now we have three ingredients for a recipe to automate the documentations by using LLM or GenAI. We can rely on consistency of the schema from CloudFormation registry that inherited to AWSCC registry. We can use existing documentations in AWS documentation page, which includes an example. And then we can use LLM as our translator. So here is kind of like the back of the napkin hypothesis. We give the LLM two things. First, we give them the AWSCC resource schema in Terraform resource schema. And the second, we give them documentation that containing example from the CloudFormation documentation page. And then we ask the LLM in here to generate an example for that same resources in AWSCC provider. Almost like just doing a translation, essentially. Okay, so now let's jump to the solutions. I want to share with you all like how we actually do this. So first, about the schema, as I mentioned, we can find this AWSCC resource schema in the Terraform registry if you browse in your browser. Then that same document is actually sourced from AWSCC repository. So here you can find that same resources in GitHub repo for AWSCC provider. It's in Markdown format, which make it super easy to do a parsing for LLM. If we open this Markdown file, here's kind of like subset of that schema that we are interested in. There are a couple things that's important in here, like which attribute are required and optional, what attribute that is exportable, available as a reference only, kind of like you can wrap it. Also, which attribute types such as string, boolean, list, map, and etc. and also like any nested attributes, which currently not shown in the screen. And then next, you want to grab the example from AWS documentation page. This example are for CloudFormation, which is in JSON and also in YAML format. We use the JSON format because it's just easier to parse it for the machine. It also contains like other resource schema, but we're not going to use it because we already have the same resource schema in AWSCC from the Terraform registry. This documentation is HTML based, which actually will require some parsing. That's why we can actually do that. Just a quick footnote, actually the same documentation are also available in AWSCC document repository. However, that repo is not up to date at the moment, so I choose to actually go just directly to the documentation page and then just parse it from there. And for the LLM, I will use Amazon Bedrock. So quick intro about Amazon Bedrock in case you are not familiar with it. It's a managed service from AWS that allows you to build and scale generative AI applications. Bedrock provides selections of foundational models from several providers such as Anthropic's, Meta, Stability AI, and more. If in case you don't know what is foundational model, it's a pre-trained model from large training datasets. And when I say large, I mean super large, like internet, for example, as the source of the datasets. Because Bedrock is a managed service, so you don't have to deal with like large infrastructures. We don't have to create a bunch of infrastructure to do training and also to run the models. You just have to use it from one API. And this is nice because later on we're going to explore different types of model, and you can use those models from a single API. Also with Bedrock, you have full control over like data that you want to customize in the foundation model, and your data is always encrypted, and transit at rest. You also own that data, so your data is not used to improve the base model, for example. And you can expect the same level of security from any other AWS services, such as private connectivities and also common compliance, such as ISO, SOC, and then also HIPAA eligible. There are also other Bedrock features that we're not going to cover in this session, such as customization of the model itself, retrieval augmented generation or RAG, or agents that execute a multiple step of tasks. Although we're gonna kind of use some of this technique, but we're not actually using the feature from Bedrock for that. So in this session, we just strictly use the prompt engineering. Now that we selected Bedrock as our GenAI for these experiments, the next question is which foundation model to choose from. All LLM are trained on text, and for this use case, ideally, you want to find foundational model that is trained on a lot of codes like Python or Java. Good thing is Terraform are widely available as a training datasets from the internet. Many blog posts, many documentation, many pages out there available that talk about Terraform. However, you have to keep in mind that the AWSCC datasets are very limited because there are not many blog or article out there that talking about it. Also, when using LLM, there's a concept called input tokens, which is like the chunk of text that we presented to the model as an input. The larger your input, the larger is the input token as well. Since we're going to present the schema and also the example in CloudFormations, this is like a moderately sized amount of input text or the input tokens. The other considerations, many of these models are trained on corpus of text in various of language like Spanish, English, French, etc. In this case, we don't really care because the schema and the example are in English. Bedrock has several LLM foundational models such as Meta Llama 2, the Anthropic Cloud, the Amazon Titans, and also a few others to choose from. For this experimentation, I will use Anthropic Cloud 2.1 for a couple of reasons. The size of the input token is quite large, 200K, which is enough for like a pages of documentation. Cloud also specifically trained on a lot of source code, and scored quite well in the benchmark for such. And keep in mind, we can always choose a different LLM later on in Bedrock, so without making any significant changes in the process. Okay, now I'm gonna show you how we do this in the practical sense. All right, so here's part of the demo. So first part, I just want to show you Amazon Bedrock and how we can interact with it through just the user interface in the console. So here I'm on the Bedrock console. I can find the list of the providers such as Amazon, Anthropic has its own provider as well, Cohere, Meta, and etc. So each of them has is a provider for the foundational model in Bedrock. And then each of those has the base model in here. And then the nice thing about Bedrock is that it also comes with the playground. So in this case, I can use the playground to create a text or a playground for image to generate an image. I use the text just to kind of show you a very high level how they interact with Bedrock. So I'm going to select Anthropic, Cloud 2.1, and apply. And in here, I'm going to say create VPC resource in Terraform. Hit run. There's a couple configurations such as the temperature, top K, and etc. This basically to handle the randomness and diversity of the model response itself. And we can see in here that the model start to generate the output. So for Terraform, VPC resources is doing a pretty good job because it's a very common resources, obviously. But let's say we want to try something a little bit more complex, such as, in this case, I want to try guard duty detector. So let's say I want to create, remove that, the AWSCC guard duty detector. So guard duty detector resource in AWSCC. And you see what the output says. So in here, notice a couple things. So it's already wrong. For example, I asked for AWS, but then the output in here is actually for AWS standard provider. So I cannot use the example when I generate the documentation. Obviously, we can do more in terms like improving the prompt to get the model to do a better job. So let's take a look into that. So in this first example, again, I'm going to use the same resources, AWSCC guard duty detector. So here I'm just defining the resource. And then I'm looking for the location of that resource in the AWSCC documentation. So this part in here is just going to look up to the actual resources in Markdown format. This is the schema. You can see in here is the header for the schemas, optional attributes, required attribute, and etc. We don't want to care about this like a metadata on the top. And also we don't care about other pieces on the bottom, such as the import pieces. We don't want this part to kind of confuse the model. So what we're going to do is that we're going to parse that document. So here I'm just doing a simple parsing using the tool from LangChain called the Markdown header text splitter. And then by doing that, I'm going to just look at and isolate this part of the schema, which is the header, based on the header on the Markdown. And then we're going to do the same thing for the CloudFormations. CloudFormation has a specific resource name, so I just have to look up for that same resource in the CloudFormation in here, based on the naming convention, of course. And then here I can find that same resources based on doing like a quick simple lookup for guard duty detector. Here's the example for guard duty. And then same thing in here, I'm going to do parsing of the HTML. Because I don't care about the syntax, properties, or return values. I just care about the example part. So again, doing the same thing in here and look up for one example that we found. And then we use the LLM. So I'm using Bedrock Chat. That's like a tool available in LangChain that provide access to interact with Bedrock. I'm using Anthropic Cloud V2. And then as part of the prompt, I want to include the schema in AWSCC, the CloudFormation example from the CloudFormation documentation, couple of rules to let the model understand and ask them specifically what the task is. So let's take a look into that. So first, I tell the model that they have to play a role as a Terraform expert in this case. And then we tell them the resource name. So this is just kind of placeholder that I'm going to inject the actual resource name. And then the schema of that resources. I'm using the schema like a marker in here in XML because that's what the Cloud 2 is pretty much trained on. So we just kind of be very well in recognizing XML. But the actual schema itself is still just a markdown format. I just put some marker to delineate the schema. And then also the example in CloudFormation, which is in JSON, right? So we have the JSON form text in here. Again, the marker in XML, so to make it easy for the model to distinguish that. And we tell them like there are rules that I have to follow, such as like using JSON encode when defining the IAM policy document, and also other things such as like don't use dynamic blocks, using data source for AWS account, using like AWS color identity. And then we tell them the tags to convert the CloudFormation example to AWSCC. And then I wanted to start the answer with this particular text and also end it with this particular text, make it easier for us to do a parsing later on. So in here, we're just running that same template for the prompt, injecting the actual resource name, schema name, and the examples, and then we generate the schema, or the actual example in this case, I mean. And after we generate the example, what we can do is that we run Terraform validate against that example from the model to validate if it's actually correct or not. So I'm outputting the file to main TF file in here, and then I'm using a Terraform library wrapper to run Terraform init and Terraform validate and get the result. So I can see in here the file and the result is valid. So I can go to the actual output for gratuity, look at the file, and here I can see that this is the file itself that's generated by the model. All right, I can use this, and then I already in fact doing that inside of my Terraform in here. So using the same resources, I'm doing Terraform plan. I can see that it's pretty much recognized by the provider. So let's do something a little bit more complex. So in this case, what I'm gonna do is that I'm gonna use this example. So this example is for AWSCC Cost Explorer Anomaly Monitor. So this is a very uncommon. So let's see if the model can also take it from the example from CloudFormation. Again, same thing in here, look up these resources in AWSCC, and then look up the same resources in CloudFormations, and then parse the data itself for the example. And looks like we found 5 examples. So there are 5 examples that needs to be generated by the LLM. So we run the LLM, again, same thing in here. And we implement the same prompt, so it does it 5 times because there are 5 examples. And then we run Terraform validate again against the same 5 resources example. And okay, looks like we've had some errors. I rerun this earlier just to kind of save some time. And it looks like for this example, service monitor, the resource tag is actually a list of objects. So we have to define this as a list in here. For anomaly monitor with tags, again, same thing in here. So resource tag, but it doesn't use equal sign in here. So that's again another mistake that has to be fixed. The other 2 examples are fine, and the last one have another problem as well. Looks like it's referring to ARN, and that ARN actually should be maybe something else like an ID, for example. Okay. Now, what we can do is that we tell the model to fix it by running the another inference based on the Terraform validate. So in this case, I'm creating a new prompt. So this new prompt has the schema, and then it's also include the output from the previous model. So in this case, here's the output from the previous one, so version 1, and then also including the output from the Terraform validate, so the actual error message. And then we tell the model to fix it based on the Terraform validate itself. So now we run the same inference again, this time only against 3 resources because there's only 3 that's broken. And then in here, looks like the first 2 is successful. I can find that the configuration is valid for this first 2, But the last one still have some error. In this case, it's looking for argument subscriber that doesn't exist yet. I can rerun another validation. So again, doing the same prompt again. And then in this case, just running it against one example. That's the remaining one that has a problem. And there you go. And then we find the success validation for that last resources. So let's take a look actually what happened in here. So that's for anomaly monitor, attaching subscription with monitors. So I can see in here, I have my version 1. This is the version 1. Looks like the problem was here with this ARN. And let's see if it's fixed it on version 2. Yes, so it's using the ID. So you can see in here, it's trying to fix that part of the problem. But then the subscriber, this should have an equal sign in here. And on the last version, it fixed that by adding the subscriber at the end. Okay, so that's conclude part of this demo. All right, so that's it for the demo. Just have a final word before we conclude. In these sessions, you just learn how generative AI or LLM can help to accelerate the time to generate an example in AWSCC Terraform provider. I want to emphasize that human review is still required. As shown in the demo, the model only provides the result, and then you still have to do some Terraform validate, and sometimes it requires more than one times to do the validations. And again, the solution does not create actual pull requests yet. That's something we're exploring. We're also going to look at how to keep this example up to date, maybe making it as part of regular scan, and also how to deploy this at scale across hundreds of the resources. There are some edge cases where the model might actually hallucinate, which means like more validation is also required. Lastly, how should you use and take the learning from these sessions into like a practical use? What are other use cases where you can apply this? So here's a couple ideas for inspirations. You can use this to convert existing CloudFormation template into a Terraform template, for example. You can also, maybe you want to standardize in the way your team write Terraform or ACL by introducing set of rules, like how certain resource should be defined, how to use JSON encode, and etc. And another use case would be for migrating to a Terraform module, like if there's have a certain resources, how you can migrate that into a Terraform module. And I'm sure there's some more sample of use cases that you can think of. So that's it. Thank you for your time today. I hope you find this session insightful. Enjoy the rest of the HashiCorp conference.